Okay, class. So let's start today. Okay, we're going to start with a new topic today. Direct sensing. We're done with the nuclear. We have another 3 topics to go. Then we have about 3 weeks. I think we just nice finish all the 3. Maybe 1 or 2 days before. I think maybe we might have 1 or 2 days, maybe for your revision. As I say at the background, now you should already start do your past years, your trial papers. Okay. Okay. So can you see the slide? Anyone? Can't see the slide.
Yes, can see.
Can. Okay, good. Okay, so this topic is about direct sensing. Direct sensing means like electronic sensing, directly sense the senses information and come out with the output. It's called sensing or direct sensing. Okay, first, what you're going to do, this is, I think, this topic is maybe 90% something new you never learned before. 10% you learned before. About the sensors you learned before. About the transistor you learned before. Okay, so 10%. Okay, first, what we're going to talk about in this electronic is sensing device. Then we're going to talk about what is meant by amplifier, operational amplifier, and operational amplifier circuits, and finally the output. Okay, in your electronics, in a sensors, like like a street light sensors, automatic air condition, temperature control system. So all electronics now, all chips controlling the what do you call controlling the devices, like AC, as I say, automatically switch off the air condition. So in electronic, there are 3 different departments. Okay, first department is called sensing device. Senses will be the first level of sensing the information. The sensing device can sense temperature, can sense pressure, can sense resistance. You have different type of sensors sensing different parameters. Okay, this is the first department, sensing device. Then these sensors connected to a processing unit. A processing unit is the brain of the electronic, the brain, op-amp. The amplifier is the processing unit, the brain. Like your computer, your chipset, your processor is your brain, right? The sensing device gives an input to the processing unit. Then the processing unit will decide whether to on or off the output device. The output device could be a alarm, could be a speaker, anything. Could be a light, could be a LED output device. Okay. So these 3 departments you have to remember. 1 year came out 3 boxes they asked you to fill up. The first box is what? Sensing device, sensors like LDR as a resistance change with light intensity. Processing is the what you call processing change the typical property of the sensing device. Indicate by output device. Output device is could be switched to, could be a light bulb, could be a speaker, and so on. Okay, today's lesson we will do sensing device. Okay, we have time, then we go a little about processing unit. Okay, there are 4 types of sensing device you have to know: LDR, thermistor, piezoelectric transducer, and 4th called strain gauge. 4 type. The first 2 I introduced you in AS, but as I said, LDR thermistor officially in A2 now, not in AS. So LDR thermistor, piezoelectric transducer, and strain gauge. Okay, LDR can go very fast. LDR sense what?
Light.
LDR senses light, right? When light intensity increases, what happens to the resistance of the LDR? Decreases, right? Light intensity increases, resistance decreases, voltage across LDR increases. Correct? Okay. Thermistor, temperature rise. What happened? Resistance of thermistor. Anybody? Temperature rise. Thermistor. Resistance of the thermistor decreases. Voltage across the thermistor decreases.
So voltage decreases or the current increases?
Temperature. Temperature. When temperature increases, the resistance across thermistor decreases. Voltage across the thermistor decreases.
Also the current?
Current should go up. Current should go up. But
So
voltage will drop.
okay.
Because you see, you have one fixed resistor, another one will be a thermistor. Okay, another one will be the thermistor. This R1, R2. Okay, if the thermistor resistance decreases, means the voltage across thermistor will drop because you are sharing the voltage.
Yes.
So current increasing. Okay, so LDR sends light, thermistor sends temperature. The other two, something new. Piezoelectric transducer. Piezoelectric transducer is a device sensing pressure. Okay, sense pressure. Okay, and create voltage. Okay, we will do that later. Strain gauge sense strain. Strain means you know what is strain? Extension to the original length, right? Strain. You learn under deformation of solid. So when the extension increases, the strain gauge will detect. Like you know, a building got cracked. They attach a strain gauge on the crack. They shall check in 1 month how much the crack is expanding, like a bridge crack. Let's say it expands to 0.1 micromillimeter. The strain gauge can detect that. So strain gauge detect sense strain. Piezoelectric transducer sense pressure, thermistor temperature, LDR light. Okay. First, let's view LDR. LDR, this is the symbol box and the light. It's a light dependent resistor. You know that lah. Yeah, sandwiching in film cadmium sulfide between the two metal electrodes. Resistance is about 1 megohm to. There is sunlight, high resistance. No sunlight. No. When there is no sunlight, high resistance. When there is sunlight, low resistance. Okay. So the resistance of LDR constant, light intensity. So yeah, this is the main thing. Light intensity rise, resistance drops. Okay. Okay. Next, thermistor. This is a symbol of thermistor. You have to know to draw the symbol. In exam, they might ask you to draw the symbol. Remember the symbol, like a box and a right sign. Thermistor. Okay. The resistance of the most the substance does change slightly with a change in temperature. However, the thermistor, the device that is manufactured in various shapes and sizes, the significant change in resistance with temperature. So it is found to be a greater temperature, smaller resistance. It's called negative coefficient. Your syllabus, thermistor with negative coefficient means when temperature rise, resistance decreases. Okay. Yeah, so that's the second one, thermistor. Sensing what? Temperature. Okay. Greater the temperature, smaller the resistance. Remember that. That's important. Okay, next, piezoelectric transducer. Okay, piezoelectric transducer we're going to do in depth later under ultrasound. Okay. Piezoelectric. So you see the paragraph. Let me show you what is piezoelectric transducer. Okay, just for a while we will be doing this later, but just temporarily let me show you the device. Just want to show you piezoelectric transducer. It's under medical. The wave ultrasound. You open that, you can see the picture of piezoelectric transducer. Okay, we'll be doing this topic later, but just to show you the piezoelectric transducer. This is piezoelectric transducer. The piezoelectric transducer. This is the piezoelectric transducer. Piezoelectric transducer is actually, if I go, it's a part of the ultrasound machine. This piezoelectric transducer, different type. The piezoelectric transducer sensing pressure. It's sensing pressure. Okay. In other words, pressure what? Pressure of sound. Sensing sound, different sound, give different pressure. So this piezoelectric transducer made of it's made of a parallel plate. There is a parallel plate here. It's electric field, parallel plate. Inside this parallel plate, in between the parallel plate, got some crystal. Okay, there is a crystal. Okay, I show you the crystal. How is it the crystal? So the piezoelectric transducer in between got crystals. It's a tetrahedron crystal. Silica. The piezoelectric transducer is made of a piece of quartz crystal, two opposite sides coated with thin layer of silver. So the type of crystal used is silicon oxide. SiO2, silicon oxide. Silicon at the center for oxygen. It's in terms of tetrahedral shape. Okay, tetrasilica unit. Okay, when this crystal, when you apply pressure, if you apply pressure, the crystal will start to vibrate. When crystals start to vibrate, easily it can vibrate. When crystals start to vibrate, you see this picture. The silicon is positively charged, oxygen is negatively charged. Although it's neutral, tell me which region more negative polarity, at the bottom or top? Where's more negative polarity? At the bottom, right? Because got three oxygen at the bottom. More oxygen is at the bottom. So down is more negative, up is more considered positive. Okay. In this crystal exposed to a vibration, pressure, when the crystal vibrate, what happened? The crystal will start to extend, compress. When the crystal extend, okay, when extend, a different polarity will happen. Different polarity will happen. Up may be negatively charged, down is positively charged. So this plate, because the parallel plate, create a voltage. Voltage will be created. The voltage created, the strength of the voltage depend to how strong is the negative charge happen, negative positive charge happen. How strong is the negative charge depend to how extend the crystal. If the crystal extend more, the voltage generated is big. So the pressure is small, the voltage produced is small. So this is how the piezoelectric transducer works. Piezoelectric transducer senses what? Senses pressure. How it sense pressure? Pressure go and vibrate the crystal. When the crystal vibrate, what happens? The positive, negative charge going to displace. So maybe upper side will be more negative, so become more very negative, down become very positive, create a voltage. So this is sensing pressure, create voltage. Okay, this is a piezoelectric transducer. For time being of M, you don't need to go in depth. The only thing you need to know about under operational amplifier is it sense pressure. It made of crystal, it made of electric field, all you don't need to know. But eventually you need to know for when you learn ultrasound later. Yeah. Any questions? No questions. So for time being, remember, piezoelectric transducer is a sensor sensing pressure, like pressure of a sound. Okay. Go back to the electronic. Okay, so that's what I told you is in this paragraph. Piezoelectric crystals such as quartz have a complex ionic structure. When the crystal is unstressed, the center of the charge of the positive and negative ions bound in lattice of the piezoelectric crystal coincide. However, the pressure is applied to the crystal will distort. Center of charge for a positive and negative ions will be no longer coincide. A voltage will be generated across the crystal. The effect is known piezoelectric effect. So greater the crystal displaced, greater the pressure, greater the displacement of crystal, greater the voltage produced. So the electrical connection can be made to a crystal to opposite side, crystal to coated with the metal. The magnitude of the voltage generated depends on the magnitude of the pressure. This is the important one. Big pressure, big voltage generated. Okay. The polarity of the voltage depends on whether the crystal is compressed or expanded. Increase or decrease applied pressure. That's piezoelectric transistor. Sense pressure. Very small pressure, like a sound pressure, you can sense. Very sensitive. A sound wave consists of a series of compression reaction. If the crystal is incident, a piezoelectric, it vary voltage across the crystal will be produced. This voltage can be amplified. This crystal and amplifier act as a simple microphone. Yes, the piezoelectric transistor acting as a very sensitive microphone. Very sensitive microphone. Okay. Like a heartbeat also can. Okay. Sensitive microphone. Okay, next, the fourth one is the strain gauge. Okay, 1 year came out. What is meant by strain gauge? 2 marks question. You're supposed to write this. Strain gauge is made of sealing a length of very fine wire in a small rectangular thin plastic. It's called strain gauge. A fine wire was attached to a very thin in a rectangle of thin plastic. A very fine wire. These are the two connections. If these two wires are pulled, the fine wires start to extend, resistance increases, so voltage increases. So strain gauge stands what? Strain. Stands strain. Okay. So strain gauge, plastic stretched, and plastic stretched, the wire also stretched. This causes the wire length to increase, its cross-sectional area to decrease slightly. So this both increase the R. When R increases, voltage across the strain gauge increases. In a potential divider method, you have one fixed resistor, another one is the strain gauge. Strain gauge, okay. So here, when this resistance goes up, so the voltage across strain gauge will increase. Okay, big resistance use big voltage. Okay, so these are the 4 senses. Okay, this is R plus changes of R. R is changes R rho, changes of L over A. Greater the extension, greater the changes in resistance. Okay, so these are the 4 senses. The sensors will be communicate with the processor by using a potential divider method. It's a potential divider method. We have a battery. So this is a sensor. Okay, maybe you put a thermistor here. Thermistor senses the temperature of the room. Temperature rises, the thermistor resistance goes up. Sorry, resistance goes down. Voltage across here goes down. This voltage is sent to the operational amplifier. Amplifier to check whether to on or off the AC unit. Okay. So sensor's job just sense the value, just change the voltage. The changing voltage will send to the processor to think whether to on or off the output device. Okay. So again, how many devices you have? You have 4. LDR, light goes up, resistance goes down, voltage goes down. Thermistor, temperature high, resistance goes down, voltage across thermistor goes down. Piezoelectric transistor made of crystal uses electric field. When a slight pressure is applied, such as the sound, pressure creates the voltage. Greater the pressure, greater the voltage. So sent to the output. Strain gauge is used to check cracks in buildings, in bridge, check how far, how much it extended. Even a small, less than a fraction of millimeter also the strain gauge can detect. Okay, so checking strain. Okay, any questions so far? No questions, Okay, so we're done with the first part. First part is senses. Okay, now we go to the most important part, which is going to take 3 lessons maybe, discussing about the brain, operational amplifier, the second department. Okay. Operational amplifier is actually these chips is an integrated circuit like IC. I think the one amplifier size will be maybe 50% of the 5-cent coin or 10-cent coin. 50% of 10-cent coin is the size of this amplifier. Okay, it's called operational amplifier. Operational amplifier function is, of course, amplifying the signal. Maybe the signal is too small. The signal from the sensor is very, very small, maybe millivolt, maybe microvolt. But this amplifier amplify the voltage to many times. Normally, it can capable to increase the amplify the signal to 100,000 times. 100,000 times. That means 1 millivolt can become like 100,000 millivolt. That means 100 volt. So that's amplifying. Okay, so although it looks like a box, but inside the circuit is complex. As inside the circuit is like this. As I told you last time, it made of these small units called transistors. I think, as I said, more than about 20 over transistors in that one op amp. Okay, multiple amplification done before it give out output. Okay, but although this is complex, but there is a symbol for us to draw operational amplifier. The symbol is this. This is the symbol. This is operational amplifier symbol. Operational amplifier always will have two input, negative input, positive input, and the side one is the power supply, and this is output. Okay, here each leg, maybe the first two leg here, maybe one, and you see here, each leg covers this legs lah. V plus was in the 7, V negative in where? V negative in the 2, 7 and 2. So V in and V plus and V minus. Every leg carries one of the junction. Any questions? Operation amplifier. Okay. Okay. This operational amplifier has a 5 properties. Ideal operational amplifier. Ideal means what? Perfect operational amplifier. Like last time, transformer got ideal transformer got some efficiency, right? What is ideal transformer means? A transformer which has an efficiency of 100%, right? So ideal op amp is a perfect operational amplifier. A perfect operational amplifier has a 5 character. It's all something new for you. Okay, the 5 character. Out of these 5 character, 4 character has an infinite value. 4 character has an infinite value. 1 character has a 0 value. 4 infinite, 1 0. Okay. The first character is the operational amplifier has an infinite input impedance. Okay, what is meant by impedance? Okay, impedance means you can take it like resistance lah. Resistance. Impedance is like resistance. You see, okay. Okay, let's say you have a power supply, you have a resistor, you have a 2 resistor. Then we say the circuit got resistance, but the circuit got capacitor. The circuit got something called inductor, which is not in your syllabus. Inductor is like a coil of wire, can create magnetic field. You got a capacitor. Okay, the circuit contains capacitor, inductor, and resistor coexist together. Do capacitor oppose current flow? No? Do capacitor keep opposing the current flow? Oppose the current flow, right? Sometimes when charging, you learn that, right? When charging, capacitor will build up its voltage, you oppose the current flow. Right? So capacitor as a factor that oppose the current flow. Okay, similar like resistance. Resistance also something a factor oppose the current flow. Right? But the term resistance is not used in capacitor. To have a common term for all of them, it called impedance. It's called impedance. Impedance means the effective factor that opposes the current from flowing. It's called impedance. So for your understanding, you can imagine impedance like resistance, like opposing the current. Impedance also unit is ohm. Okay, ohms. Okay. So the operation amplifier has an infinite input impedance. Means what? The input when the current flow, the input, the resistance to flow the current is infinite. That means technically, the input current is like zero. No current flows into the op amp technically, because it has an infinite input impedance, very high resistance. The factor that opposes the current flowing. So the input current is zero normally. Okay. So it has an infinite input impedance. Okay. Second, I go another infinite. It has it has an infinite input impedance. It has a zero output impedance. Zero output impedance means what? Means what? When the current comes out, when the current comes out, output here the impedance is zero. That means current is said to be infinite. From no current, you get infinite current. This is called ideal operational amplifier. Why input zero current? You say infinite impedance. Impedance is infinite, so zero current. Why output infinite current? Because zero impedance in output. Impedance means what? Like resistance. So infinite input impedance, zero output impedance. Okay. Then let's we go the other three. The third one is infinite open loop gain. Open loop gain. What is gain? Gain is actually output over input is called gain. Output over input gain. Okay. Let's say you give input 2 volt, output you got 10 volt. Output you got 10 volt. 2 volt become 10 volt. What is the gain? Gain is 5. Gain is 5. Gain is 5 because 10 divided by 2. Output over input is your gain. How many times it was amplified? So yeah, so gain means what? V out over V in. It's your gain. The op amp, ideal op amp has an infinite gain. Infinite open loop gain. Now we call it open loop gain. Open loop, I'll teach you later. For time being, it has an infinite open loop gain. Okay, that means what? You give one voltage, but the output voltage like infinite, very big. A small input can give a very big output. Infinite open loop gain. Okay, that's the third one. Okay, the fourth one is called bandwidth. It has an infinite bandwidth. What is bandwidth? Bandwidth is a range of bandwidth. Ideal of as an infinite frequency response. Bandwidth means I tell you what is bandwidth. Okay, what is meant by bandwidth? Okay, this is not an internet bandwidth. This is electronic, slightly different. So let's say you have an op amp. You have one ideal op amp. Say that the gain is gain is, let's say this is a practical one. Let's say you have a gain of 10. This is a practical one. Gain is 10. That means if you give input 1 volt, output will be 10 volt. Okay. So let's say opera singer sing and the sound was changed to a voltage set into the operational amplifier. She sing with the peak of 1 volt amplitude. So when output, the sound going to be enlarged with how much? With 10 volt. That means the loudness increased by how many times? 10 times. Okay. So that's the operational amplifier. But this operational amplifier has a certain frequency response. It has a certain frequency response. You say, let's say the opera singer sings from 20 hertz let's say the frequency of the op amp is 20 to 10,000 hertz only. 10,000 hertz only. Okay. Meaning what? This value 20 to 10,000 frequency. This is called bandwidth. This value is called bandwidth. That means it's what? If the opera singer makes a frequency 1 volt with a frequency of 20 to 10,000, okay, it will be amplified 10 times. But let's say the opera singer suddenly increased to 11,000 hertz. Okay, suddenly she make a high pitch sound, 11,000 hertz. It's already out of the bandwidth of the op amp. Then what will happen? Op amp won't give gain 10. It won't give this gain 10. It might give gain 3 maybe. Okay, that means it never works at the optimum level. The gain is only 10 when the frequency is within the bandwidth. If the frequency exceeds the bandwidth, then the operational amplifier won't give that gain. It becomes less efficient. Suddenly the sound becomes less louder. This is called bandwidth. Okay, what is bandwidth? Bandwidth, a range of frequency where the op amp works at its optimum level. That's bandwidth. Bandwidth is a range of frequency where the operational amplifier operates at its optimum level. Optimum level means you say gain 10 means you give gain 10. That's all bandwidth. Tell me, good or bad to have a bigger bandwidth? Good to have a big bandwidth, right? If you have a very big bandwidth, any frequency you send in also you're going to amplify with 10 times. So no distortion, we call it. Any questions about bandwidth? So please write, what is meant by bandwidth? A range of frequency where the operational amplifier works at its optimum level. Okay, so that's bandwidth. Let's go back. The ideal operational amplifier has an infinite bandwidth. So it's a huge bandwidth. Very infinite. Any frequency can process with the correct gain. Okay, it's called bandwidth. Okay. And the last property of ideal op amp is infinite slew rate. What is slew rate? Slew rate means processing rate. Processing rate. You send a signal, don't think the signal going to come out immediately. It might take maybe 2 microseconds. So the 2 microseconds, maybe that's the processing time. Because you need to pass through all the components until output will come out. Reasonably small is 2 microseconds. Okay. So slew rate means the delay, how much is the delay? Okay. Infinite slew rate means zero delay. Remember, infinite slew rate, very low slew rate means less delay. Time is short. Okay. Infinite slew rate means what? No delay in the processing. Operational amplifier has an infinite slew rate. That means slew rate is measured the time delay between the changes to the input and output. With an infinite slew rate, there is no delay. No delay. You see, op amp question, out of 12 paper 4 question, 1 question definitely comes up from op amp. Op amp got 1 question always. That 1 question, the first question they will ask most probably, what is the property of ideal operational amplifier? 1 year they ask about, write 3 properties. So out of these 5, you need to know at least 3. Remember, a fact to remember, infinite input impedance, zero output impedance, infinite gain, infinite bandwidth, infinite slew rate. These are the 5 properties of ideal op amp. Any questions? Guys, no questions. Okay, so remember this back. This is all something new, something new you are learning. Okay, now this is ideal op amp, but practical op amp, this is all not infinite and zero. It has some value. The most important value you need to remember is the gain. The others you don't need to remember. The others, the actual value you don't need to remember. The real op-amp has the impedance all has a value. It's not infinite. It's big lah, but not infinite. But the most important value you need to know is the gain. The real op-amp has a gain of 10 to the power of 5. By how many times? 100,000 times. A real op-amp can reach amplification of 100,000 times. That means input you give 1 volt, output will be 100,000 times. That means if the opera singer sings any songs, the sound can be amplified 100,000 times. The real op-amp. Okay. So remember this figure. Huh? Okay. So now we're going to go in depth about how the op-amp give out output. Okay. It will have two input. One called inverting input, another one called non-inverting input. Non-inverting is given for the positive terminal, non-inverting. Okay. Negative is called inverting input. These two are power supply connected to the op-amp. The power supply normally very small, normally 6 volt, less than 6 volt. It won't be very big voltage because op-amp is a IC, integrated circuit. Integrated circuit, very intelligent, but cannot withstand very high voltage. It will burn down. Okay, so we use a very low voltage, around 10 volt, less than 10. Okay, and this IC going to analyze these two input and it decide to give out output. The formula the op-amp follows is this formula. This is the formula, the golden formula the op-amp use to give out output. V out equals to gain times with the differences between the input. If V plus greater than V minus, if the V plus greater than V minus, output going to be positive. If plus greater than minus, output is plus. If minus greater than plus, output will be minus. So check who's the winner. If positive greater than negative, output will be positive. Okay. If the output is positive, most likely the op-amp going to on the output device. Later you will have output device. Output device, which could be an alarm, can be a light bulb. So you on it normally is output positive. Okay, so this is the formula, remember. A naught is the open loop gain. Okay, of the op-amp. Now the A naught, we take it as how much? 10 to the power of 5. 100,000. Okay. Okay, now the circuit is growing. So the circuit, the input will be 2 voltages. Down here, this is the earth sign. Earth sign means 0 volt. Here 0 volt. You put a battery in between, or you can put a microphone, something which can generate a voltage. These two at the end could be a sensor. Sensor in the potential divider method to give out input voltage. This is a power supply. This power supply. These two power supply. Normally given same. 9 volt, 9 volt. So input will be positive 9 or negative 9. Okay. The others no need to remember. Okay, for an example. See, positive is positive 9. Negative is negative 9. Sorry. This is the power supply. Power supply is 9 and negative 9. Power supply determines the output. So now the input V positive, V negative is V positive 1.4, V negative is 1.3. So operational amplifier receive for 2 input. One is 1.4, another one 1.3. So what the op-amp will do? You go and calculate output. Output is A naught 10 to the power 5. V plus is 1.4 minus 1.3. Output is 10,000. So the operational amplifier will instruct to give output of 10,000 volt. Okay, 10,000 volt is very big, The op-amp just instructing to give out 10,000 volt. But who going to give the 10,000 volt? The power supply. The power supply follows the instruction of op-amp. Like op-amp is like the manager. The manager said to the bank to give cash of 10,000, 10 million, let's say. Let the cashier, let the customer, what do you call, withdraw 10 million ringgit. Okay, 10 million ringgit. The manager instruct, okay, give him 10 million ringgit. But in the bank, the amount of money they possess only 5 million at that moment. Can they give the 10 million out? They can't. So what they'll do? They just give whatever maximum value they have. They got 5 million, 5 million will be given to them. So same thing, same story here. The op-amp is like the manager of the bank. He only instruct. But who going to give out the money? How much of money in the what do you call, in the bank? Okay, the bank here, that is bank. Here is will be the power supply. Power supply only capable to give from 9 to -9. It means the output, the op-amp say 10,000. The supplier can't give 10,000 because its limit only +9, -9. So what the supplier will do? Supply only give out +9. Only give maximum he can. It's just because positive 10,000. So positive value you can give maximum is +9. So output will be +9. You just give out output +9. This process called saturation. Saturation happen. Okay. So as I said, this is not possible. 10,000 not possible. The output voltage cannot exceed the power supply voltage. The amplifier is said to be saturated. So V out will be the power of the voltage. So any questions from here? No questions. So understand, the operational amplifier can give out any power, it can give any output. But who going to give the output is the supply. Supply, if the output instructed by the op-amp exceeds the power supply, the power supply will be, the output will be saturated to the maximum value of the power supply. Okay. Okay, this case, positive is the winner. Positive is more than negative, so output is positive, +9. Normally positive means as I said, the output later, the third department never appeared here, later will appear. The output will be switched on normally. Okay, another example. In this case, negative was bigger than the positive. Negative was 3.654, positive is 3.652, negative bigger than positive. Now the power supply is only 6, +6, -6. So these two input to the formula, the output is found to be -200 volt. So the op-amp when instruct gives -200 volt. But again, saturation happens. So the supply only can give -6, so it gives -6. So the output will be -6.
So
Yep.
So if the supply is, let's say, infinite, then only then we can reach the, let's say,
You can give. Yeah, correct.
Oh, okay. Thank you.
Okay. Yeah. So the amplifier is saturated. This called saturated. In exam, when they give this number, you calculate, you got -200 volt, right? You know the answer is -6, so you put -6. Sometimes you lose mark. You put -6 in bracket, you must say saturated. You must say stated, you must state saturation. The value is -200 volt, but answer is -6 volt. In bracket, you put saturated. Saturated will be normally 1 mark. The wording saturated. Okay, so this is how the op-amp decide how he thinks. He use this golden formula. If positive greater than negative, it give out positive. If negative greater than positive, it give out negative. Negative means normally don't on the output, don't on the power. What do you call? Maybe the alarm or street light. If positive means on the street light or alarm. Okay. Okay. This case, V positive bigger than V negative, but very small margin. In this case, we put these two values inside and we found it's 10 volt. It's positive 10 volt. So the supply is 15, positive, negative 15. So in this case, what happened? I give the 10 volt, I just give the 10 volt. Okay, this case the amplifier is not saturated. Okay, but very rare happens. Normally saturation happens. Okay, question also asked, why the op-amp easily saturated? What's your answer? Why the op-amp easily saturated? Because it has a very huge what? Huge? Because of this 10 to the power of 5, right? Because it has a huge gain. The gain is huge, 10 to the power of 5. Small difference times with 10 to the power of 5, the number going to be very big, right? So why op-amp easily saturated? In exam they'll ask, why the op-amp is easily saturated? What's the answer? You say the op-amp has a huge gain. It has a huge gain. That's why it's easily saturated. Okay. Any questions so far?
Teacher, what does saturated actually mean? It means that like how?
That means the supply unable to, can't afford to give the requested voltage.
Requested voltage. Oh, okay. So that means that the wait.
It's saturated already. That means you just give its maximum value it has. It's called saturation happen.
Oh, so that means that the supply, for example, supply is 6, but the output is negative to 200 volts. But since it's only 6 is the maximum, so it will only give 6.
Yeah, that situation called saturation happen.
Okay.
Okay.
So that means the output must be lower than the supply line voltage.
Then it can vary. Yeah.
Okay.
But is it saturation going to happen frequently? Common? Yes. Saturation is very common in operational amplifier. Okay, very common. Okay. Yeah. So one example. This the question tells you that to prevent saturation, the differences between V plus V minus must be 9 times 10 power negative 5. Very small differences will avoid saturation. It means what do you conclude here? Easy to become saturated or difficult to become saturated? Difficult, easier to become saturated. Very easy saturation happens. Okay, a small difference. This is very small. Normally the differences will be slightly bigger, so it's saturation definitely going to happen. Okay. Okay. So any questions up to here? Okay. So now we go into the last part for today. The last slide. Okay. This is the slide. Okay. This is already take the two department together. The sensor connected to the brain, operational amplifier. This is how the sensor will be connected to the operational amplifier. The sensor will be connected in a potential divider method. Okay, so that it's going to sense the environment change and its resistance going to change accordingly. When resistance change, the potential divider causes the voltage to be changed, and the voltage input to the op-amp will change. So the op-amp just decide whether to on output or not. If positive bigger than negative, it make it on. If negative bigger than positive, you make it off. Okay. So in this case, tell me, in this case, you see here, this is earth sign. Earth sign means what? Is 0 volt. It's all are 0 volt here. All are 0 volt. Okay. Let's say here you give 9 volt. Okay, positive 9 volt. 9 volt. That means up here is positive 9 volt. Sorry, I don't want to put 9. I put 10 easier. Positive 10 volt. Here positive 10 volt. See, all the potential is positive 10 volt. Here positive 10 volt. Okay. What is the voltage at here? How much voltage here? At point A here. You see point A? Okay. So you see, up positive 10 volt, down 0 volt. Two resistance R. So upper resistance take how many volt? 5 volt, right? Because same resistance volt. So down R will take 5 volt. So what is the voltage at A? 5 volt, right? 5 volt lah. At A is 5 volt. So the negative input, the V negative is 5 volt. Okay. Okay, now remember the voltage negative will be same as the bottom voltage, the voltage of the bottom resistance or the top resistance. The voltage at A is going to be same as the voltage of the bottom resistance or the top resistance. Okay, let's say for example, I didn't give you R and R lah. On top I give you 3R. On top is now 3R. Down is R. What is the voltage at A? Top is 3R, down is R. What is the voltage at A? What is the voltage at 3R? Voltage at 3R. 3R, R. The ratio of the resistance is the voltage utilized by that resistance, right? 3R, R. What is the voltage used by 3R? 3R divided by the total resistance, right? For R times the differences. What is the potential differences? 10, 0. So 10. So the voltage used up by 3R is how much? 7.5 volt, right? What is the voltage of the R at the bottom? 2.5 volt, right? What is the voltage at A? 7.5 or 2.5?
2.5.
2.5 volt. It will take the bottom resistance voltage. So remember, voltage at the junction input is always the voltage of the bottom resistance. So A is 2.5. Okay. Okay, so this is how it works. Okay, let me clear this. So here R. So here 10 volt, here 0 volt. So the V negative is found to be 5 volt. 5 volt. Okay, now tell me, LDR is fixed here. When do you think likely the output become positive? When LDR, when light intensity rise, what happened to the resistance of the LDR? Decreases. What happened to the voltage across LDR? Decreases. When the voltage across LDR decreases, the input B, the V positive, will decrease or increase? Will decrease. Okay, will decrease, right? So V positive will decrease. When V positive decrease, output most likely become positive or negative. V positive decrease. So output most likely become positive or negative. Negative. So it won't on the whatever output device, or maybe street light. Okay. So this is a street light circuit. When the light intensity is very high, when a sunny day, early morning at 7 o'clock, when the street light, there is a LDR in the street light. The LDR sensor, when the light intensity increases, the resistance of the LDR will go down. The voltage across LDR will go down. So the B input positive will start to drop. V positive will start to drop compared to the V negative. Outputs immediately turn to negative. The light bulb will be shut down. Okay. This is the automatic switch. This automatic switch. This is the circuit used for street light. Sensor is LDR connected to op-amp. What is the function of op-amp here? It acts as a automatic switch. Hey guys, do you understand the circuit?
So that means that the light will only, like for example, if light will only turn on if it's positive.
Yeah. When the output positive, the light will turn on. When negative, the light will turn off.
Also, it depends on the position of the LDR.
The LDR indirectly controls the output.
If the LDR puts up, then positive is off, negative is on.
Yeah. Maybe in the night time, light drops, resistance goes up, positive become negative, street light will on.
Okay.
So no need to No need to manually go and switch on and off. The sensor will take care of the switching system. Actually, not sensor lah. Sensor together with the operational amplifier works together to on and off the street light. It's automatic switcher. Okay. Okay, guys. So I stop here. Time's up. But this is the introduction lah. Tomorrow we will continue with this. Okay. So what you learn today? You learn about 4 sensors. You learn about op-amp introduction. What is the formula followed by the op-amp and the 5 properties. Okay, I stop here. You can watch the online videos, your seniors one down there. This all already taught. You can prepare if you want. Okay. Any questions? Questions? Okay, guys. See you tomorrow. Okay, bye.